Yes, today we'll start with the interpreter files. Okay, so what is the meaning for the interpreter file? So these files are the text files that begins with the line of the form. So any of the file that can be started with the hash with respect to the path name and followed by the optional argument. So then we're going to call it as a interpreter files. So here the any space between the exclamation point and the path name is an optional. If you look into this, the path name and as well as the this exclamatory sentence, so it is an optional function. Okay, so either we can include this one or we can exclude this one. So and also always all the most of the common interpreter files it can be begins with the slash bin and followed by the slash sh. And next, so this is what the diagram which will helps to show that how the interpreter files will going to work. So here we have started with the system slash wait dot it. So we have started with the main function. In the main function, we have included the processor ID. So if the processor ID, if it is equal to the fork function or if it is less than to the 0, then the error, the system will going to give the error that is an fork error. If not, if that value is less than 0, if it is not equal, then the condition will move here. That processor ID is equal to the 0. Then if that execute function, so then what it will going to print it will going to print the my followed by the argument. So if you want to look into this example, so how we're going to execute this file by using the output that is a dot slash that followed by the out. So first it will give the print the value that is argument vector of 0 and argument vector of 2 and as well as the argument vector of 3 and the 4. So here that is printing the my rgc1. So that is what here the same reflecting, and again it is printing the my rgt2. So this is what how we're going to represent the interpreter files. And next is the system function. So here the system is used to invoke the operating system. It is in the form of a C or C++. So here we are calling the standard library function. So to include the system functions, we are using the command string. So that is nothing but the constant followed by the character command string. So this is a simple program which can explain the how the command strings will going to be work. So here int main followed by the system. So multiple system. One is a ls command, clear command, gcc command, dot slash a dot out command, and as well as a cd command, which is used for the changing the directory file name. And again, this is one of the important program, the system functions without the signal handling. How the system's functions will going to taken without using the signal handling. So we are started with the main thing, that is the argument counter and as well as the argument vector. If the stated argument counter, if it is less than 0, less than 2, then the command line arguments are required. If that status, if it is less than 0, then it will going to print the system error condition. So this is the one thing. And again, if the command string value is equal to the null, then it will going to return the value with the 1. So if not, it will going to give the value with the status as equals to -1. So this is a program which helps to show that how the signals will going to be handled. So without using any signal handling functions. Yes, so and again it can be continued in the form of like whether the status if that is less than 0. So what will happen? And again, if that value, if the date will going to be printed and the no such command. So if the status is equal to date, then the date will be printed. If any of the command, so the wrong command if you are given, then it will give the no such command will be going to be printed. And again, if the status, if you're going to give the value, so then that particular value will going to be printed by using the system handling functions. So further, this is what the output will going to accept here. So that is sh is nothing but the command. So no such commands will going to be found. And if the command it can be execution, then the normal termination and as well as the exit status can be printed as the output. Okay. So next is the process accounting. So here in the process accounting, the main thing is the Unix system will going to provide an option to do the process accounting. So this Unix will helps to produce the process accounting. So what is this process accounting? When enable, the kernel writes the accounting record each time process will going to be terminated. And these accounting records are typically small amount of the binary data. And again, the super user executes the action without the path name. So if you need to execute any of the process accounting, a super user will going to execute with the path name, and this accounting records are to be written with the specified file name. If you are going to maintaining any of the accounts or record, you have to maintain with the specified file. So the data required for the accounting records, such as the CPU and the number of characters transferred, that is kept under the kernel. If any of the data which I am required for doing the accounting section, so then that complete data I am required for the accounting process, that can be present in the CPU, and it can be transferred into the number of different kernel processor. Each time that each accounting, whatever you are doing, that each accounting is written when the process will going to be terminated. So this is what the structure we have given. So the structure of the accounting record. So here it can consisting of the multiple structure, and what is the acceptance and what is the description. For example, if you look into the time underscore t, so the acceptance is nothing but the b time. So that is nothing but the starting of the calendar time. And again, if it is user ID, so that is a real user ID, and G is the group ID, and again the compact, that is a read or the write. Either the user can read the data or the user can accept the data. So here the same thing, the values of the flock. If it is ASU, then it is a super user privileger. If it is a code, then it is a dumped code. And if it is a expand, that is a expanding the accounting into the entry. And this is very important. The diagram which shows that how the process structure will be done. If the parent, it will create the first child. So how it is going to creating the child? By calling the fork function. So initially it is a sleep 2. So then the first child, it can be increases to the sleep 4. And again the first child will become the parent child. And again it will create the one more child, that is known as a second child, by using the fork function. Again here the second child, either it can produces the third child by using the fork function, or it can call the exec function to store the path name. At the final, it will go into third child will be created. Sorry, the fourth child will be created by the fork function in the third sleep exit time. So this is how the data will be going to access in the process structure of the examples.